So basically we're just checking that we've got the right well. Our field tools will tell us, but our GPS coordinates or even location sketches is what we used to use. So nowadays we use aerial photos, so we know that it's in the yard of Kāinga. We know that we're looking for a upstand well, 6-inch casing, and we also know that on this particular well we measure at top of casing. It is always the same measurement, it never changes, and this is highlighted by a fluorescent mark that has been surveyed by the surveyors to an RL1. So as we arrive at site, we're checking first two things. Our probe is going. On these ones we have a test button, so we know that we have a current. We then dip these wells to a water level, and when it starts making a noise we know we've hit water, which it has. So now we back it off to get water out of the column on the probe, and now we measure until, can you hear that noise? Yep. So we've struck water. Yep. So what we're doing is checking that when the buzzer goes off we know we've contacted water. So we visually look at the top of the casing, and when we pull it up we know exactly, it's exactly 1 metre 640 millimetres to the top of the casing. So periodically as the measuring points fade and rust away or they just start to disappear, we respray them. We keep a can of fluorescent paint in our truck, so we now are respraying the original MP, and we know that that will always be measured at that point. Points are the ones that are surveyed as a known datum. So what we do from the known datum, once it's been surveyed, we will measure from the measuring point to ground level. As you'll see here, ground level is more or less the concrete pad here. So that is our ground level reference point. So we will measure that to there, and again we eyeball it, and we know that it's exactly 260 millimetres above ground. And once we've done that, we will then enter it into our database. So then it allows for our reference from measuring point to water level to ground level. So again, we've arrived on site. We're checking for this well here, BW24. We're looking for a PVC casing with an internal pipe. PVC casing, internal pipe. We know that it's a 40mm diameter pipe, so we know we're at the correct bore. We know that the measuring point is top of the PVC. We have a spray point for a measuring point. And our ground level reference will be the same as the previous one. This is our top of the casing, measuring point. This will be ground level. So we measure from this point to the top of the casing. Ground level can change, measuring point will not. First things first, we know we've got our well. We're using a narrow probe for this one because of the narrow diameter hole. Again, the principle is the same. We will always test it to make sure it works before we start. So we have a contact. The contact on this one is that point here. These are just weights to make it go below water. So the contact on this one is just this metal part here. So we'll put that down the hole, same as the other one. And until we hit water, we pull it out. Now we're looking for the top of the casing measurement. So, as you can see, if we look at the top of the casing there, it has hit water at 582, but it will be 1 metre 582. So this is what we call our fat probe. So this was 100 metres long. So these are calibrated once a year. We run these out on a Wigram Air Force Base under tension as if it was hanging from 100 metres. If this reel is any more than 100 millimetres out over 100 metres, we throw the tape and start again. We do it for all our tapes, so once a year everyone has to do it. We then do the same for our narrow probes. Now these ones here require less tension, they weigh less, so therefore the tension that we put on these at 100 metres is less than the ones we put on these ones. Again, anything over 100 mils we will throw out. The most important part of all these probes to us, 0 to 10 metres. They are the most common depths of water for us. And that would be it.
So you would check at what increment from that?
This one's checked every metre up to 10 metres. Then we check every 10 metres, 20, 30, 40, 50, 60, 70, 80, 90, 100. If it becomes 100 metres and 100 millimetre, we throw it away.
Okay.
And we will reinstall a new reel, which we will then recheck, even though it's new. We have found some that have errors on their tapes, but it's come out in the wash when we've stretched them and found there was gaps missing of 100 mil
Oh, really?
in the middle of our tape. But again, throw the old one, put a new one on, recheck that is accurate, and then we know that our water levels we're taking are within 1 millimetre accuracy.